Hello, this is Mrs. Scarpel, and this is part 2 for Unit 2, Lesson 4, B square. So we are picking up with example 8, and here Optima realized that not everyone needs perfect squares and not all orders are going to come in as expressions that are. So we're going to determine whether each expression below is a perfect square and why the expression is or is not a perfect square. If it is not a perfect square, find the perfect square that seems closest to the given expression and show how the perfect square can be adjusted to be equivalent to the given expression. So let's take a look at example A. We have a of x equals x squared plus 6x plus 13. Well, when we're completing the square, we know we need half of 6, which is 3 squared, is going to be 9. So we have more than enough for a perfect square. If we draw a diagram for this, we have the x squared, that is going to be x by x. And we need to divide that 6 evenly between these two rectangles, and half of 6 is 3. So that each rectangle is going to represent 3x. And when we look at the units, we have a 3 by 3, which is going to give us 9. So we can write for our expression a of x equals x plus 3, those are the dimensions of our square, and since we have 13, that's 4 more than the 9 we had in our units space. So we need to add 4. So because we have extra, this is not a perfect square. If we take a look at example B, we have a of x equals x squared minus 8x plus 16. So again, half of 8 is 4, and 4 squared is 16. So this is a perfect square, and we can show that with a diagram. We have our x squared, which is made up of x and x. We need to divide up or split up the minus 8x, so that will be a negative 4 and a minus 4. So each rectangle is representing a negative 4x for a total of negative 8x. And then negative 4 times negative 4 is plus 16. So we do have a perfect square, and we can write this as a of x equals x minus 4 squared. And again, this is a perfect square. So your perfect squares will not have anything added or subtracted to them. With example C, again we have an x squared, so that's just one block. We need to split up the minus 10, so that's going to be minus 5, each rectangle representing a negative 5x. Negative 5 times negative 5 is going to give us 25 units. Well, that's far away from negative 3. So what would we have to do to 25 to get negative 3? We're going to have to subtract 28. So our equation is a of x equals x minus 5 squared and remember that gave us a positive 25. We need a negative 3, so we have to subtract 28. D has a 2x squared. So that's going to be 2 blocks each with an x squared. And then that 8x has to be divided between the 2 blocks, so half of 8 is 4, but then 4 has to be split up between 2 rectangles. So that's going to be 2. So each rectangle is going to represent 2x, and the units are going to be 4. Excuse me. 4 plus 4 is a total of 8 units, but we have plus 14, so we're going to have to add another 6 units to this. And I should make a note on our previous one that we had to subtract 28 units. So our equation will be a of x equals x plus 2 squared plus 6. Example E has 3x squared, so that will be 3 blocks. Each with an x squared. And we have negative 30 to divide among the 3 blocks. So 30 divided by 3 leaves me 10 for each block. And I need to split that 10, so we have negative 5 for each side, because each rectangle is going to be negative 5x. And then we have negative 5 times negative 5 is 25. And 25 3 times is 75. So we do have 3 perfect squares. And our equation is a of x equals x minus 5 squared, but I can't forget I'm multiplying this by a 3, so we should have a negative 3 in front of that x minus 5 squared. Example F is going to be a little bit different. So the 2x squared tells me that I'm going to have 2 of these squares, which is fine. And then the 22 needs to be split up between the 2 blocks. Now that's 11. So we're going to have an odd number that we break up here. That means I have 11 over 2, a minus 11 over 2, to be subtracted from each side. And I'm using fractions here so that you get used to seeing fractions and you can practice working with them. Excuse me. So when I multiply 11 over 2 times 11 over 2, that's 11 times 11 is 121 over 4. Now, I need to find out how much that is total. So 121 over 4 added to 121 over 4 is going to be 242 over 4, which simplifies to 121 over 2, because 2 goes into both 242 and 4. So I need to find out if I have more than enough, or if I don't have enough to meet this 11. So what I'm going to do is I'm going to take the 121 over 2, and I'm going to subtract 11. And if I subtract 11 and I have a positive number, that means I have too many, and I will have to subtract. Now, in order to do this subtraction, I need a common denominator, which is going to be 2. So 11 times 2 is 22. 1 times 2 is 2. And then when I subtract, I'm going to end up with 99 over 2. That's positive. So I still have more than what I need. So I'm going to end up subtracting 99 over 2 from my two perfect squares. And the final equation is going to be a of x equals 2 times x minus 11 over 2 squared minus 99 over 2. So now that we have worked some out, let's take a look at some takeaways. For x squared plus 6x plus 13, I'm just going to start by writing that expression again. And I'm going to draw a picture. I only need one block. That's going to be x by x, but an additional 3 on each dimension. So that's going to give me x squared plus 6x plus 9. And I need to have 13. So that's going to mean I need an extra 4. So the factored form will be x plus 3 squared plus 4, because 9 plus 4 gives us 13. Here we have 2x squared plus 8x plus 14. Again, I'm just going to rewrite. I'm going to draw 2 blocks. Each with an x squared. Now keep in mind, we have to split up this 8 over 2 blocks. So that's 4 per block, but 2 per side. And our units end up being 4. So I'm going to write this as 2 times x squared plus 4x plus 4. So 2 times 4 is 8. We need 16 more. So in factored form, this becomes 2 times x plus 2 squared plus 16. Not 16, should be 6, excuse me. Because we said we had 8, we need 14, so we're going to add 6. And there we have written standard form into a vertex form, so when we get to lesson 5, we can graph these as well. Our retrieval, we're stating y-intercepts and then matching the graph with its equation. So the y-intercept for this particular graph, remember the y-intercept is where the graph crosses the y-axis. This particular y-intercept is located at 0, -3. If I look at my equations, I see that 2 of them have a -3. Everything else is the same except one of them is a negative x squared and the other is a positive x squared. Well, if you remember, when your parabola is upside down like this, when it's flipped, it's going to be a negative on the first term. So our equation here is b, g of x, equals -x squared plus 5x minus 3. Same set of equations, different graph, but the same y-intercept. Well, we've already used b, and the only other equation that has a -3 is c. So this equation is c, h of x equals x squared plus 5x minus 3. And our third graph, also open up, but it has a positive 3 y-intercept, so 0, 3. The only equation we haven't used is a, and it's also the only equation that had a plus 3 at the end. So the equation here is f of x equals x squared plus 5x plus 3. And for the last of our retrieval, find the indicated values for g of x equals -x squared plus 5x minus 3. We're going to substitute these values in for x in our function. So for g of 2, we're going to have negative, and then in parentheses put the 2, because what's being squared is the number, not the negative, plus 5 times 2 minus 3. And then we just simplify. So we have a negative, 2 squared is 4. 5 times 2 is 10. Subtract 3. Negative 4 plus 10 is 6. Subtract 3 is 3. So g of 2 is going to equal 3. G of 5, do the same thing. Replace x with 5. So negative 5 squared plus 5 times 5. Subtract 3. And we have a negative 25 plus 25. Subtract 3. So negative 25 plus 25 is 0. Subtract 3 is negative 3. So g of 5 is negative 3. And finally, g of negative 3. So this time I'm replacing all of my x values with a negative 3. So this time I am going to square a negative number, but it's still going to be negative in the end because of the minus sign in front, or the negative sign in front. So we're going to have a negative. Negative 3 squared is 9. 5 times negative 3 is negative 15. Subtract 3. Negative 9 subtract 15 is negative 24. Subtract 3 is negative 27. So g of negative 3 is negative 27. And this is the end of lesson 4 of Unit 2.